Hello, my name is Johan Lee from Red Labs, and it is my honor to introduce the AI Ed Challenge 2020 winners. Why did we host this challenge? Three reasons. One, we wanted to expose more people to the field of AI for education. Many scientists aren't aware of the possibility of applying AI to education. We hear concerns from teachers that AI may replace them. This is false. We want to provide tools to help teachers and help teachers do what they do best, which is engaging with students. Two, we wanted to put a spotlight on the shortage of large-scale data sets. In order to drive research in this field, more high-quality, large-scale public data sets is needed. The AI Ed Challenge was a catalyst to help spark others to join us in this endeavor. Three, the goal being to find the very best ideas for our learners today and for our learners of tomorrow. To ensure that we check their biases, we wanted an open competition for the very best solutions for state-of-the-art models from anyone and everywhere on the planet. In short, we are always in search of doing better for the learner. The Kaggle task centered on knowledge tracing, KT, a well-established problem in the field of computer-assisted education. The goal of KT is to model a student's knowledge through learning activities over time. Improvement here means that resources can be suggested to students based on their individual needs, and content which is predicted to be too easy or too hard can be skipped and timed correctly for presentation at the right time. We believe KT is a fundamental domain to help develop a personalized educational agent that provides learning paths adapted to each student's ability and needs. RID is one of the first startups from Korea to host a large-scale global Kaggle challenge at this caliber. We wanted to start our foray in this space with the highest standard to benchmark and inspire others to follow. When choosing the competition task, we considered either fundamental and accessible methods like correctness prediction and knowledge tracing, or something relatively unexplored like content recommendation. We chose number one to lay a foundation for future challenges. We thought a well-structured and designed competition would initiate a virtuous cycle for year-to-year advancement of the field and not a one-time challenge, the aim being exponential impact. With regards to the IP of the winning solutions, we intend to make them non-exclusive and non-commercial, meaning open to the public, where commercial use is not allowed with the code or the models. The task itself was to accurately predict how students would perform on newly encountered questions based on the student's previously learned activity. The input was each user's history of learning activities given in chronological order. The output was the expected correctness probabilities for each newly encountered question. To evaluate, we used the ROC-AUC, where the model output is compared against the actual correctness label. The data consisted of 1 million students worth 123 million interactions. This is sourced from RID's TOEIC exam tutoring system, listed in chronological order. The training and test set was split by time, so that past interactions were used to train the model to predict the future interactions. The features we provided were interactions, such as the question solving lecture watching, time, duration, content picked, and the user answers for each interaction. The learning material metadata was comprised of the content tags, the TOEIC part number, and the correct answer for each question and lecture. And now we'd like to switch over and talk about the submission API. We wanted to simulate the real world as much as possible. Hence, we designed the submission API to model our own product experience. Allow me to illustrate. The model essentially goes through a loop, iterating each test interaction one by one. In the beginning of the loop, the information on the test interaction, excluding the user response and duration, is given. So the model must predict the user responses to the given test interaction. After the prediction, the actual user response and duration for the test interaction is given to the model. This allows it to predict the next interaction using all previous interactions, including the one that just got predicted, just like a real-life educational agent would do. The loop iterates to the next interaction, and the model repeats itself. The outcomes. While our RID researchers have experimented extensively with variations of deep learning-based KT models, the results of the Kaggle competition showed performance that far exceeded our initial expectations, advancing the state-of-the-art of KT a little further. Each of the 5 winning solutions use deep learning approaches, which affirms that advances in deep learning are dually capable of boosting AI performance in education. Allow me to introduce each of the winning models. First place was Kitar, Sung Ki-jun from South Korea, a solo competitor. The approach was using only the last interaction to reduce time complexity. The model implemented a very interesting strategy using the last interaction only for query. While unorthodox, the approach was shown to be robust, especially after having done ensembles. It was impressive, especially given the low number of features, and the methodology's results were quite astounding. Second place, Team Mamas. This is Takashi Oya from Japan, again, a solo competitor. The approach was strong feature engineering with intensive architectural search. The model was created through many iterations and deep thinking about transformer inputs. Also, the number of features, over 90, were engineered from the dataset was quite impressive. The thorough search through the architecture was truly inspirational. Third place, Team Noisy Students, Javier Martin and Andres Torrubia from Spain, a 2-person team. The approach was a modified attention mask using containers and a very well-grounded transformer network. The model was created with a high understanding of the EdNet data. The feature engineering done was quite reasonable, and an appropriate use of ordered items for the container IDs to implement an attention mask was well thought out. Fourth place, Team Emmy from France, another solo competitor. The approach was a time-aware attention with high-level features. The model utilized time components very well in their implementation. Using longer sequences was an obvious yet difficult task that required careful consideration and technical engineering. Also, the validation strategy used in the model was a very interesting approach. Last but not least, in 5th place, Team GFHS from Chengwei Zhang, GCY95GCY, Mercurial Zhang, and Yang. This was from China, a 4-person team. The approach was an interesting architecture with strong ablation, with a unique application of user and exercise embeddings. The model was very unique in how it used a transformer network for the EdNet data. The method to use exercise embedding and user embedding in the encoder and the decoder separately was quite interesting. The level of ablation done to find the architecture was very impressive. In particular, all the winning solutions use transformers, an attention-based model first introduced with uses in machine translation by Vaswani et al. It was also adopted by RID researchers. This shows that the value of transformers is quite clear. The innovative ways the Kaggler's used them were both academically and practically interesting. These were highly creative applications of transformers that were unexpected by our researchers. In conclusion, the competition confirmed there is a tremendous amount of interest in AI education from the Kaggle AI community. The challenge served as an entryway for new data scientists to get exposed to AI ed and use real user-generated data to explore freely. This inaugural challenge was just the beginning of making more breakthroughs in the field. We would like to sincerely thank all the 4,412 participants and the amazing 64,678 models that developed as a result of this competition. We look forward to tackling more complex, difficult AI challenges in the next iterations. One example we're thinking about is NLP-related tasks combined with education. After hosting this challenge, we look forward to partnering with other educational or government institutions who may be interested in these events in the future. Thank you.